Hello again. Today we're going to talk about multiple topics. Let's see the no. Yeah. So we're going to talk about different topics because this will be our final session, and we'll try to complete as many topics as possible. Okay. And even topics that we missed on the previous sessions, we will go through them here as well today. So, and yeah, ACL also will have to go through it, and yeah. So let's start with the first topic, which is the difference between IPv4 and IPv6. I've talked about IPv4 and I haven't talked about IPv6. Okay, so there are many things. Yeah, remember we said that IPv4, like there is addresses are limited. Okay, there is only 4 billion, right? And that's why because of the limitation of IPv4, they have invented something called NAT, right? NAT is the reason why we are still using IPv4 right now, because it allows you to have unlimited number of IP addresses, internal IP addresses, private IP addresses, and you can convert it to a single public IP address, right? So so that's the main things that we need to know about IPv4. However, IPv6 has around 100. Yeah, it has more. 340 trillion addresses. Okay. Unlike IPv4, this is not limited. IPv6 is not limited. Okay. يعني link local, it will look like this basically. Automatic, no config needed, and global unicast. The IP address will look like this. Okay. So the only thing that we need to remember for IPv6 is this command, IPv6 address autoconfig. This command lets device automatically generate its own IPv6 address without DHCP. This mechanism is called SLAC and is widely used in real-world network. Okay, for us, for the real-world networking, this is what we need to remember. This is a command that we configure. Okay, and wireless, what actually works? Okay, about wireless. Okay, few things that we need to keep in mind. Okay, we have two frequencies, 2.4 gigahertz. Okay, and 5 gigahertz. Okay, 2.4 gigahertz has to be configured into one of these three channels. That's it. 1611. Okay, always remember that it should be configured in one of these channels. Let me open one an actual IP access point that is available here, and I will show you in the configuration. 1 second. So this is my IP range actually. Yeah, so this is an access point saying TP-Link. Let's try this one, 192.168.1.10. Okay, and this is how it will look like. It will have a username and password. Let's try this. Yeah, so now we are inside our access point. Okay, so basically an access point will have this stuff. Okay, this is the wireless. Okay, this is what I'm talking about, 2.4 gigahertz. Okay, this is a wireless radio. Okay, and yeah, 2.4 gigahertz SSID. SSID means the name, like this is the name of the access point. Like when you go here, okay, you will see Almetless here, right, on Wi-Fi. This is what we call by SSID. Okay, and VLAN ID, in case you want to put it on a separate VLAN. SSID broadcast enabled. This means like it's showing it's broadcasting the SSID. Security, yeah. So basically this is 2.4. This is a channel. Right now it's using automatic. Okay, this is okay if you have it will automatically select the channels from here. This is okay if your device is like new and you're not in a dense environment, like you don't have that much access point near each other in your environment. Okay, yeah, there is no chance for interference, then that's fine. But in case but it's best practice, okay, in case you want many close access points, okay, near each other, and there's a chance of interference, then you have to use this one. You have to use either channel 1 here, or 6 from here, or you can also use 11. This is for 2.4 gigahertz. Okay, and this is TX power. This is like the distance, the maximum distance the access point can go. Okay, this is 20 dBms. Okay, this is the maximum. As you can see here, it's usually 20, right? Like you can reduce it also, so that's also possible. So basically this is 5 gigahertz wireless radio. The 5 gigahertz, it's okay, and you can use as many any number you want from here. Okay, because it has more non-overlapping channels. Okay, and then we have here the same concept applies here as well. This 5 gigahertz wireless radio. Okay, and then what we need to know is the wireless security, the wireless the security. Yeah, the security. Let's go back here. Wireless security standard. Okay, now what we have seen was the wireless radios, right? We have two. Talked about this, and now you have to set actually the security standard for each, okay, separately. Okay, what kind of security standard to put on both. Okay, you can have either one. You can disable, for example, 2.4 gigahertz, which is recommended, by the way, in production environments. It's better to use 5 gigahertz always. Yeah, because it has less interference and it's faster. Actually, it's better in performance. 2.4 gigahertz, don't enable it unless you absolutely need it. Yeah. Another difference is that 2.4 gigahertz, okay, actually travels a longer distance than 5 gigahertz. Yeah. 2.4 gigahertz has higher range, okay, than 5 gigahertz, but also it penetrates walls better than 5 gigahertz. Okay, this is less range but faster. Basically, that's what we need to know about that. And this is the wireless security standard. Okay, we have WPA2 personal PCK. This is where most of the companies use this. Most of the real world use this one. Uses AES encryption. Okay, most common, 99% of small to home networks. Securance is inherent. Yeah, use pre-shared key. Okay, WPA. And WPA3 is the latest standard. Okay, newer standard. Better protection against password attack. Not supported on all devices yet. Just know it exists. Important for theory. That's enough actually. And this is what we shouldn't use. WEP. This is actually can be hacked easily, and it's not secure. And yeah, in minutes. automatically wrong. Okay, and newer standard, yeah. So basically that's what we need to know in this. Let's go to the wireless security here. Yeah, I think it will allow us to do it from here. If you go here, for example, to point 4, click the edit button. Right now my password, my security mode is no, it's actually WPA or WPA2, right? Okay, this is not actually secure. It should be this one, WPA2 PSK, because this is saying both supporting WPA and WPA2, right? We should do it this one. We should click this one, WPA2 PSK. Web is actually removed now. It's not showing here, and this is how you set the password. And see, the encryption is AES. We can use AES. It's correct, and then you can save it. This is how it works. So that's it. And basically these are the things that we need to know. Okay, and we have to know also the wireless modes. Like we have here, you can see that the wireless mode section, you have here for 2.4 gigahertz 802.11n only, right? This is this is the mode that it will support. 802.11b G mixed, BGN. These are the modes. Like this is, we call it Wi-Fi 4, Wi-Fi 5 also. Like the latest is actually Wi-Fi 6, right? This is Wi-Fi 4. It's older version. We are telling it that right now it's configured in BGN mixed. We are telling it to support all this device, because some devices don't support N, yet some device only supports B or G, right? So that's why we put it this way. We have also here AC and 5 AC only, 4. So these are the wireless modes. Let's see, let me show you the wireless modes. We have 802, 802 ABG, this one. There is a table here. I will show you. Let me show you from the beginning. This one. So these are the things that we need to know. Actually, this is useful. Now this table. Okay, do you see this table? 802.11b. Okay, it supports both 2.4 and data rates is this. Channel width supported this one. Okay, so this is actually the speeds it will support. Okay, this is the oldest one. This is G and A, N, and then AC. Most of the networks you'll find are either N, AC, or AX. Okay, AX is actually Wi-Fi 6, the latest one. Okay, it can go up to 1.2 gigabits per second partial stream, and it can support more channel widths than the older versions. This is Wi-Fi 5. Wi-Fi 5 actually only supports 5 gigahertz. Okay, up to 866 MB. Okay, this one only supports 5 gigahertz. So basically, these are the key things that we need to know. Okay, and that's about it. We will configure an actual access point on next sessions. We'll have one lab where we will cover everything, all the 2 stages. We will go through it. Basically, this is actually it. The configuration of the access point. We have to just make sure that the DHCP is disabled usually. and we can do that like, and some access point is already disabled. I think 1 second, we can do it. Yeah, some access point we have to disable it manually, and this is the system logs, and this is LED control, like if you want to check this switch, if you want to access SNMP, and basically that's it. So you can also use a wireless controller for this if you want to manage this access point centrally. If you have many access points, you can configure wireless controllers. You can update the framework from here, and that's about it. Yeah, let's check. Let's go through the next topic, which is FHRP. FHRP is basically, yeah, let's say you have two different routers. Like, let's say you have this deployment 1, 2 here, and you have let's put one switch here. Let's put one PC here, and let's put one switch here. Okay, and we will do it this way. Okay, let's put yeah, let's assume that we have an internet here. Okay, let's put anything here. Let's put a server or whatever. Yeah, let's put a server here. Okay, and let's assume that the server is actually on outside of our let's assume that the server is actually an internet. Okay, no, let's just cancel that one, or cancel this one. This doesn't have ports. I just add one port here. Let's see, let's try now if it will work. Available port, so it's okay, and we can just remove it. Actually, we don't need it that much. We can just put any router here. Yeah, put any router. Okay, on the top. Okay, we will just assume that this is actually the internet. Okay, so this is the idea of this. Okay, let's say you have this PC, okay, and you have these two routers. Okay, this is the internet. Okay, let's put here the internet. Internet. Okay, so we want to go through to this one. Okay, there are two paths, two ways, from here or from here. We can go through it in both ways. So FHRP is a way like to set a virtual IP, okay, that will choose between these two. Like if this if this is down, it will make this one active. Okay, then we will go through this. If this is down, it will revert back to this one. Okay, we'll go to this one. This is for redundancy. If one fails, the other one will take over. So, okay, now we're going to configure the internal config IP address 192.168. Actually, we don't think we need to do that. Yeah, 192.168.1.3.255.255.255.0. No shut. Get then standby. Group will be 10. Okay, and we will call it 192 IP 192.168.1. 1. Okay, this is the virtual IP. Then standby, then priority will be 110 because I want this router to be the active router right now. Standby 10, preempt, like it. Yeah, so if standby 10 preempt. So if this router like if this router fails, the other router will be the active one. But when it gets back up, it is online again, it will return back as active. That's what we did actually. Okay. Yeah, so let's do the same configuration here. No. Enable config T and T0/1 and IP address 192.168.2.1, 2.3, 2.2, 255, 255, 255, 255.0. Okay, no shut, and here I'm going to make it standby, then it's a group number, and IP is going to be 192.168.1.1. Okay, so it's actually supposed to be the same subnet, or else it won't work. So let's make this one standby IP should be this one. Okay, then standby. Yeah. No, we configured 2 here, right? This port is 1.2, so this port has to be different actually. One second. IP address, let's make it 3. No here, and let's make this one 3. Okay, so we have configured the virtual IP already. Now let's just configure the priority. I'll keep it 100. Okay, so it becomes standby instead of preempt. Spelling mistake here. It's preempt, pre-e-m-p-t. So that's about it actually. We can confirm do show standby brief. Yeah, so as you can see now, this router is standby. Okay, this one. Okay, this one is standby. Okay, state standby. So now if I send any packet, it's going to go through here. So I'm going to go through this one. Okay, if you want to confirm, let's just disable this one, for example. Okay, like let's first save this configuration. Yeah, but already we moved this one, right? Do show IP interface brief. Yeah, so let's test it out. Let's just block this one. Okay, let's save it first, do right, and then let's reload. Do reload. Yes. So now this is restarting. Now let's go to the standby router and check what happens. So as you can see, you see this notification is telling you state standby to active. It's active now. You see this one? It's active. So this is basically how it works. Okay. Now give it some time. It will be standby because this one we just restarted. So this is how HSRP works. Okay, these are the configuration that you need to understand. Standby. This is the virtual IP. How to configure the virtual IP. Priority. The higher the priority makes the router primary. Standby preempt. يعني take back off if it comes up again. Higher priority means default is 100. Okay. So now let's talk about QoS. QoS is actually this is useful for voice. Okay. يعني what we need to know is like we have this three concepts that we have to understand. Classification is like mark voice as a priority. Like for example, we have different data, right? Data, voice, data, other stuff. يعني how does it know which one is priority? So we can use classification here. It marks voice as a priority. Like the voice does it first. Okay, this is how it actually works. Okay, in depth, how voice get marked as a priority. Okay, for example, Cisco IP phones mark its own packet. Okay, voice audio plus DHCP 46 plus QoS 5. So basically are configured to mark their own RTP voice packet as this and signaling this as this. So this is how the IP phones mark the packet. Okay, then the switch trusts the phone. The phone sends packet, and this is Cisco phone. I trust its marking, so it preserves this one. But we don't trust PC. Yeah. So basically, yeah, that's it. What if device don't mark? Manual classification. We can classify it manually here using by the port number. Just this is the port for permits any UDP RTP packets. Our ports are this one 16384 to 32766, and we can permit or deny this. Classify IP subnets, merge traffic from the smart classification. So this other concept LLQ actually works. This is basically like a queue. Okay, the actual process priority queue gets special treatment. Okay, so you can make like the voice priority, and you will have like 20. You will get 20% guaranteed. Always goes first, but don't exceed 20. Like you can mention this policy. What this means: voice packets always jump to front of the line. Okay. And even if 100 MB of data is waiting, okay, one voice goes first, but limited to 20% of the bandwidth, so it can't starve other traffic. Okay, so that's the idea of LLQ, priority queue plus CPU. Yeah. Policing and shaping for voice. This is policing voice. You get 20% of pipe, no more voice traffic at this. So basically setting a limit for voice traffic, because voice is delay sensitive, not low sensitive. Okay, and bad voice dropping is better. Okay, trust, don't remark if device mark correctly. Yeah, you can trust the device. Yeah, usually the Cisco IP phones will mark the voice packet by themselves. This is called the first stage classification. And LLQ and policing, priority with limits. You can set priority, and with limit you can set for the voice packet. And one-way delay is less than. Let's measure this packet loss and jitters. LLQ minimize this. Reinforce. That's what we need to know about QoS. Mostly we will learn more about it in voice if we had a course about IP phones. Okay, and that's it. This is the DHCP Relay, same concept. Okay, let's finalize the session and we will go to let's start with DHCP Relay. This concept is actually previous. Then we will also talk about CDP, NLDP, LLDP. We didn't talk about this previous session, and then we can close the session, close the subject, the course actually. A DHCP relay is a simple concept. Let me explain to you the concept first, and then we'll make one lab. Let's assume that we have one router here, and you have one server here, and you have a switch here, and we have two PCs here, and we have gigabit fast Ethernet here. So this is let's assume this is a DHCP server, okay, and yeah, and these are the PCs, okay, but we have to keep in mind that the DHCP packet doesn't go through the router actually. Okay, so this, if we configure this, let's try to do it. 1 second. Let's try to configure it. Okay, let's try to configure it. Exam enable config t int g00 no shut, and the IP I'm going to keep it 192.168. IP address 192.168. 1.255.255.255.0, and that's about it. And int g0/1 no shut. I'm going to give it 192.168. IP address 192.168 2.1 255.255.255.0. Yeah, no shutdown. Okay, so this will be 2.1, this will be 1.1, and let's set up the DHCP. The DHCP server is going to be 192.168.2.2. okay, and yeah, 192.168 2.1. And let's put one pool here. Let's name it yeah, just name it anything, and let's just put the default gateway here, 192.168.1.1, and the DNS server 8.8 8.8. Yeah, this 2.2, and that's about it. Now add this one. So no, the IP actually has to be 1.2. So add this one. Yeah, remove this one. And we have to remove this one. Remove. Yeah. Okay, and 192.168.1.1, and this is the DNS server, and this is 1.2, and add this one. So that's it. The DHCP configuration is done. So now let's go to the PCs and let's use the DHCP. Yeah, the DHCP request failed. The reason for this is that the DHCP packets use broadcast. Okay, so it's not going to go through the router. These PCs will never get the IP from this server. So the only thing that we can do right now is configure the DHCP relay. It has to be configured on this port and facing the LAN, so pointing to this server in order for the species to get the IP address. Let's do it now. Okay, we will check here, put this one here, and we're going to configure R1 int G00 and no IP helper address. I'm gonna give it the IP of the DHCP server, which is 2.2.2. Done. So now let's do it again. You got the IP. DHCP request successful, and you got the IP here. Okay. 192.168. So basically that's the concept of the DHCP relay. Okay, that's what we need to know. So we're just pointing to the main server. And CDP LLDP, this is the last topic, exit. And CDP is a way to identify other neighboring Cisco devices. Like for example, to enable CDP we use this command, CDP neighbor CDP run. Okay, and to check we can use show CDP neighbors. Yeah, so I can see that we have one neighbor here, the switch. Okay, see, this is how it identifies the neighbor. Do show CDP neighbors. Okay, this is basically how it works. Okay, you can disable it by clicking no CDP run. Okay, just remember these two commands. Okay, and one more topic we have to check is actually access list. Access list is the like, okay, access list is like we have two types of access list. Standard access lists. Okay, like we can use this command, access list, or we can the IP access list. Yeah, access list. Okay, let's start with the standard. Okay, the standard we can just type standard here, standard, and give it a name. Let's name it block PC2. No, just block block let's block pink, for example. Oh yeah, because yeah, we can do it this way. Okay, so now we can just deny this address which is we're getting here 1.2, right? So deny this IP 192.168.1.2, deny the wildcard bits 255. Yeah. So that's deny this IP. We just denied this IP. So let's try to paint. No, let's first add it in the interface. Int T0/0 IP access group. This is how we use the access group. I'll say block pink in outbound, صح? Yeah, outbound. So before enabling this, let's just try to ping here. So we are going to continue. Yeah, so let's try to ping /t ping 192.168.2.2. Yeah, right now we can ping the so let's just enable this one. Okay, block the ping, block ping. So yeah, as you can see now, once I block this one, the ping stopped. Okay, so this is how access list works. So what I did is, like, I configured an access list here, standard access list here, to block any outbound, to deny any traffic that goes outside of this. There's one thing, permit, 1 second. I want to check one thing, config T. So exit. So now let's just go to the IP access list, standard block and let's do the so this is how we configure the access list. Let's just permit any and remove that one, or remove that, or remove it altogether, right? You can just exit and remove this, this access list altogether. You don't need it now. So let's try the IP access list. So that's about it. Yeah, let's try one extended access list. Extended access list is the most commonly used. Like the concept is like, say, like it's called block ICMP or something. ICMP, yeah. Here we're done, and then we can say like deny. We can actually do the permit. Okay, we can permit ICMP on this address 192.168 dot on 1.2.1.2. Okay, and the source wildcard mask 255, and we can permit any destination. Yeah, any destination, any wildcard mask, any. So now I permitted this PC to make the ping, but however this PC I want to block it. Yeah, this is the difference between extended access list and standard IP. This standard, you can only define the source. Extended, you can define the source, the destination, and you can also buy the port, all that. So I'm going to deny all here. Deny ICMP any source to from any source to 192.168.2.1. No, to any. Leave it to any. Okay. Destination, to make it any. Just prevent ping altogether. So exit, and then go to the int G0/0 and IP access group. I'm going to define what's the name of the access list that we created. Block ICMP, right? Block ICMP out. Done. So now let's try to ping. We'll try to ping from both 1.1 and 1.2 and yeah, we'll try 1.2 and exit. Ping, yes, and let's try to ping this one. Ping T. Let's check. It's actually saying request timeout for both. No. So let's go ahead and try to check what we did there. I think it's this deny. the okay, let's just IP access list, IP access list. Extend it, and I'm going to mention here the block CMP, and let's see what we did here. No, not this one. This one, I think. No, not this one also. Yeah, this command I used to permit 1, 2 to any. Permitted from this, and deny. Let's just deny that specific IP address 3 here. Let's just deny this one, deny this one, deny. Yeah. So let's go to int G0/0 IP access group, we block ICMP, no, it's actually here, block ICMP, and we're going to block outbounds. So let's check it out. Blocking them on both. There is few points that were missed. Okay, this automation. Okay, what we actually gets used. We have Ansible config management YAML file, Python this one. So we just have, this is the JSON example. You will see everywhere. Security password policy that works, minimum 12 characters. Okay. And change every 90 days. It's recommended to change every 90 days. Use multi-factor authentication for admin access. And wireless security in 2024. Small network. SDN is like usually each switch makes its own decision, right? But here SDN means we will have a controller that tells the switch what to do. And central management, faster change, less human error. That's the best. So in the next session we are going to it's going to be our last session actually. So we are going to talk about the most we're going to make a lab. Okay, we're going to set it up. This lab, we're going to do this lab. Okay, we will have one ISP router on the top, one router, core switch, access switch, and 4 PCs. We'll have VLANs, we'll have uplink, access, DHCP snooping, all this routing and management, NTP, this all this protocol that we learned until now, we will implement it in one lab. In this lab we are going to make it like we're going to implement all the best practices and steps that are used in the real world configuration, and yeah, make sure that it's going to be like comprehensive, so don't skip it. It's very important. Actually, it's the most important part of all of the whole course, because we are going to do it how it's done in the real world. Like we'll configure NAT, DHCP snooping, port security, VLAN, DHCP relay, STP, HSRP, NTP, all of everything that we learned until now. We're going to put it in one lab. Okay. Then thank you for watching, completing the course, and see you next.